Hello, this is the review for the first trigonometry exam. Let us start by adding two angles, alpha and beta, given in degrees and minutes. Alpha is 12 degrees 49 minutes and beta is 18 degrees 50 minutes. We can add degrees and minutes separately. So alpha plus beta will be 12 plus 18, 30 degrees. And let us add minutes also. 49 plus 50, 99 minutes. But 1 degree equals to 60 minutes, and we should not use more than 60 minutes in this form. So we must represent 99 as 60 plus 99 minus 60 will be 39, so 99 equals 60 plus 39 minutes. 60 degrees is the same as 60 minutes is the same as 1 degree, so 1 degree plus 39 minutes. So alpha plus beta will be 30 degrees plus 1 degree plus 39 minutes. 30 plus 1, 31 degrees and 39 minutes. In the next problem, let us convert 4 revolutions per minute to revolutions per second. So we deal with the rotation of a disk or a wheel. So 1 minute is 1 second in 60 seconds. So if you don't remember, either you should divide or multiply by 60. Just think about, well, either there are more revolutions per 1 second or less. Yes, of course, there are 60 revolutions less in 1 second than in 1 minute, since second is 60 times shorter time period. So we must divide 4 by 60, and then we get revolutions per second. Let us simplify these fractions. 4 and 60 are both divisible by 4, so we divide by 4 numerator and denominator. We will get 1 in the numerator and 60 over 4, 15 in denominator. 115 revolution per second. So with that problem, we are given the angle alpha equals 80 degrees. We want to find its supplement and its complement. So the sum of supplementary angles equals to 180 degrees. So if theta is a supplement of 80 degrees, then theta plus alpha must be equal to 180 degrees. So to find theta, we subtract from 180 the measure of alpha, which is 80 degrees. So the supplement is 100 degrees. If the theta is a complement angle, then theta plus alpha must be, so let us denote this prime. Theta prime plus alpha must be equal to 90 degrees, or theta prime equals 90 minus alpha. Let us substitute 80 for alpha. 90 minus 80, 10 degrees. In the next problem, we have a triangle given. The angles of a triangle and one external angle are connected to each other. So, and we have one unknown variable x. Let us denote angles with letters to make it easier. A, B, C. What can us call this angle? C, the acute angle on the pictures, the inside angle of the triangle. So what can we write about these angles A, B, and C? A plus B plus C equals 180 degrees for every triangle. What else do you know about this? We have a straight angle here, and the angle C and angle x plus 120 are supplementary angles. So angle C plus x plus 120 must be equal to 180 degrees. So the right sides are equal, so we can set that the left sides also equal to each other. A plus B plus C must be equal to C plus X plus 120 degrees. We can also substitute the measures of A and B. 5x plus 2x plus C equals C plus X plus 120. So we can subtract C from the left and from the right and simplify this equation, finding the like terms. So 5x and 2x, 7x equals x plus 120 degrees. Subtract x from the left and from the right, 6x equals 120 degrees. Divide by x, and we get x equals 20 degrees. If the problem asks you what is x, then the answer is here. If the problem asks you to find the all angle measures, then we need one more step. So we substitute x and find the measures of the angles. Angle A equals 5x, x is 20, so it is equal to 5 times 20, 100 degrees. Angle B equals to 2x, 2 times 20, 40 degrees. And angle C, it is equal 180 minus x plus 120, or minus A and minus B, or 180 minus A plus B. So what is easier? Either so or so. 180 minus A minus 100 and minus B minus 40, so equals to 40 degrees as well. So the actual triangle doesn't look exactly like the triangle shown in the picture, but it's only a of this triangle and x. In the next problem, two similar triangles are given. In the first triangle, we know all three sides. In the second triangle, we know only one side length, and we can determine the side lengths of two other sides. So we can set up a proportion. So we have one pair of corresponding sides that are both known to us, 4 and 12, or 4 over 12. The same proportion will have the four other sides, A and 10, or B and 15. So we have all three pairs of proportional sides. So we can find A and B taking one of the equations. So in this form we have two or even three equations in the same moment. Let us take one of them. 4 over 12 equals A over 10. If you multiply this proportion by 12, you don't need to cross multiply as you usually solve the proportion. You just multiply by 10 the whole equation, then you get A on the left and 4 times 10 over 12 on the left. So let us simplify this fraction. You can divide by 4 numerator and denominator. 12 divided by 4 will be 3, so A equals 10/3. The second proportion will be B divided by 15 equals, this take the same known fraction, 4/12. This time we multiply by 15 the equation, since we want to get B isolated on the left. Then B equals 4 times 15/12. We divide, to simplify the fraction, we divide by 4, numerator and denominator. 12 divided by 4 is 3. And then we divide by 3, numerator and denominator. 15 divided by 3 will be 5. B equals 5. Problem 6. The point 6, -8 is on the terminal side of angle theta. We want to find cosine theta and sine theta. First, let us draw this point in Cartesian system and determine the quadrant. So the x-coordinate is positive x, positive 6, and the y-coordinate is -8. So this is x, this is y. So our point is in the fourth quadrant. To find trigonometric function of this point, we need actually 3 values. This is the terminal side of the angle. We don't know whether it is a positive angle or negative angle, but we don't need to know this information. We need to know R to use the definitions of trigonometric function. Let us consider the right triangle with one leg equal to 6, another leg equal to 8, and find the hypotenuse. So the sum of legs squared, 6 squared plus 8 squared, must be equal to hypotenuse squared. (36 plus 64 equals r squared). 100 equals r squared. R equals the square root of 100, or r equals 10. We don't need to write here plus minus, since r is always positive. R is the distance from 0 to this point. So the point 6, -8. So we have found r. Now we can use definitions of trigonometric function. Cosine of theta is by definition x over r. Sine of theta is y over r. Substituting x and r, we get 6/10. We can simplify this fraction while numerator and denominator are both divisible by 2. Let us divide 6 by 2 is 3, and 10 divided by 2 will be 5. 3/5. Sine of theta equals y over r. We substitute -8 for y and 10 for r. And also we simplify this fraction by dividing by 2, numerator and denominator. 8/2 is 4, -4, and 10/2 is 5. So the sine of theta is -4/5. Of course, sine is negative in the fourth quadrant and cosine is positive. Let us evaluate the following expression. 5 cosine 180 degrees minus 3 sine 270 degrees plus cosine 360 degrees. All 3 angles are quadrantal angles. So on the unit circle, the terminal sides of each of these angles on one of the axes, positive or negative. Let us start with 180. 180 is a straight angle. You can take any point on this negative x-axis, and its cosine will be x over r. X is negative on the left from y-axis. So, and the absolute value is the same as r, so the cosine will be negative 1. So let us take the radius equal to 1 as on the unit circle. So this point is negative 1 and 0. The distance to the point r is 1. Negative 1 over 1 is negative 1. The next angle is 270 degrees. So 270 degrees is this angle containing of 3 quadrants. So this is 270 degrees. Let us take a point on the unit circle. So the distance from the origin is 1. X coordinate of this point is 0 and y coordinate of this point is negative 1. Sine is y over r. Y is negative 1, so sine of 270 will be negative 1 over 1 or negative 1. Cosine of 360 degrees. 360 is 1 complete rotation. So if we are on the unit circle, we will consider this point. Its coordinates are 1 and 0. X coordinate is 1, y coordinate is 0. So we are interested in the cosine of this angle. Cosine is x over r, so 1 over 1. So cosine of 360 is 1. Let us multiply 5 by negative 1 minus 3 times negative 1 plus 1. So negative 5 minus 3 times negative 1 will be plus 3 and plus 1. Negative 5 plus 4 will be negative 1. Problem 8. Given that cosecant x equals to negative 5, find sine of x. So sine and cosecant are reciprocal of each other. So we can find sine of x using the reciprocal identity. Sine x equals 1 over cosecant x, or 1 over negative 5, negative 1/5. Problem number 9. Given that sine theta equals 3/4 and theta is in the quadrant 2, find tangent theta. So we need to sketch this angle in the second quadrant. Sine is positive. It's normal for the second quadrant. So we know that sine is y over r. So let us take y equal 3 and r equal 4, since sine is 3/4. So y equal 3 and r equals 4. And this is the point on the terminal side of the angle. So we want to find the trigonometric function of this angle. So we need a third value. We know y, r. We need to find x. So let us consider this right triangle. One side equals to 3, one leg. Hypotenuse is 4, and the third side equal to x can be found by Pythagorean theorem. X squared plus 3 squared equals 4 squared. So the side itself is equal to absolute value of x. The x coordinate of this point must be negative, don't forget. So x squared plus 9 equals 16. Let us subtract 9 from the left and from the right. x squared equals 7. To find x, let us take the square root from this equation. When we take square root, then x must be equal to positive or negative square root of 7. And since we are in the second quadrant, x is negative. We choose negative sign. X equals negative square root of 7. Now we can find tangent of theta. Tangent of theta equals, by definition, y over x. Y equals 3. X equals negative square root of 7. So negative 3 over square root of 7. And we want to rationalize this denominator. Let us write negative sign in front and multiply by square root of 7, numerator and denominator. 3 square root of 7 over square root of 7 squared, which is 7. Negative 3 square root of 7 over 7. This is the value of tangent theta. Let us consider right triangle ABC with two given sides, A equals 6 units and C equals 8 units. And we want to find the unknown side length, find B. So C is, as usual, the hypotenuse of the right triangle. A is one of the sides. A equals 6, so the opposite angle will be angle A, and this is angle B, and the opposite side is unknown. Find B using the Pythagorean theorem. A squared plus B squared equals C squared. Substitute the values of A 6 squared plus B squared equals 8 squared. 36 plus B squared equals 64. Subtract 36 from the left and from the right. B squared equals 64 minus 36, or 60 minus 30, 34 minus 6, 28. And let us take a square root. B equals square root of 28. This time we don't need to write plus or minus. We know that the side length must be positive. So, and we can simplify the square root a little bit, since 28 is the product 4 times 7. Square root of product is a product of square root, so square root of 4 times square root of 7. Square root of 4 is 2, and we get answer 2 square roots of 7. Let us find the sine of negative 225 degrees. So we want to locate this angle on the unit circle. When it is negative, we rotate the terminal side in the opposite direction, the clockwise direction. Here, at the end of the first quadrant, we will have negative 90 degrees, then negative 180 degrees, and the positive y-axis will be negative 270 degrees. So negative 225 will be in the middle of the second quadrant, negative 225 degrees. To find the sine of this angle, we must find the difference between negative 25 and negative 180. So all we can just subtract 225 minus 180. The difference will be the same. We need a positive angle. We don't care about the sign of this difference. So 225 minus 180 is 45 degrees. So the theta prime, the reference angle, is 45 degrees. Sine in the second quadrant must be positive. Sine of 45 degrees is square root of 2 over 2. You can either find it on the unit circle or recall the reference triangle, the half of the square with the sine length 1 will have hypotenuse square root of 2, so the sine as well as the cosine will be 1 over square root of 2 or square root of 2 over 2. So now let us find sine of negative 150 degrees. Also, negative angle is the rotation in the opposite direction and clockwise direction. So it's 150 will be between 90 and 180, all negative. So somewhere here, negative 150 degrees. The reference angle is the angle between negative 180 and negative 150. So we need only the positive difference between them. 180 degrees minus 150 degrees equals 30 degrees. So the reference angle theta prime is 30 degrees. Sine in the lower half plane is negative since y is negative below x-axis. So sine of negative 150 will be negative. The absolute value will be equal to the absolute value of sine of the reference angle, 30 degrees. Sine of 30 degrees is 1/2, so the sine of negative 150 degrees is negative 1/2. Also, we can find this on the unit circle, the sine of 30, or we can recall the reference triangle, the half of the isosceles triangle with the side 2. If we divide this triangle into 2 halves, we'll have 1, 2, and square root of 3, the second flag. So the sine of 30 degrees will be opposite of hypotenuse 1/2. Now let us find all values of theta if cosine of theta equals to negative square root of 2 over 2 and theta is on the interval from 0 to 360 degrees. From 0 to 360 minutes we consider one complete rotation and we want to find all angles theta with this cosine. Negative cosine will be both in the second and in the third quadrant. So we will get two angles with the same reference angle and both will have cosine equal to negative square root of 2 over 2. On the other hand, we know that theta prime must be 45 degrees since cosine of 45 degrees equals square root of 2 over 2. Now let us find both theta 1 and theta 2. In the middle we have a straight angle 180 degrees. The first solution can be found as 180 minus theta prime or 180 minus 45, 135 degrees. And the second solution can be found as 180 plus theta prime, 180 plus 45 or 225 degrees. Let us also find the solution of the following equation. Cosine of theta equals positive square root of 2 over 2. So the reference angle is the same. Reference angle is 45 degrees, since the absolute value is the same, square root of 2 over 2. Angle is positive, but we still have two solutions of this equation, since cosine can be positive in the first and in the fourth quadrant. So we have two angles, 45 degrees, theta 1 equals theta prime equals 45 degrees. And the second angle will be 360 minus 45 degrees, or 315 degrees. So also two solutions. So if we solve the equation for sine of theta, then we will consider either the upper half plane or the lower half plane. So here sine theta positive, and if sine theta is negative, then we will search for two solutions in the lower half plane. But don't forget that angle theta prime reference angle is always measured with the x-axis, which is either 0 or 180 or 360 degrees. Let us find the bearing of the point 5, 5. So the x-coordinate of the point is 5 and the y-coordinate of the point is also 5. So it means that the ray coming through the origin, passing through the origin and through this point bisect the first quadrant of coordinate system. So it means that these two angles are both 45 degrees. Here 45 and here 45 degrees. We have actually two bearing methods, and we will use the first one with the second one with letters. So we know that on a standard map we have and above and south, below, east is to the right and west is to the left. And the second method of bearing starts from the vertical axis coinciding with y-axis, and if our point is in the other half plane, then we start writing bearing from N. Then we give the measure of the angle. In this second method, this must be less than 90 degrees from direction due north to direction due the point in question. So 45 degrees. And then the last letter shows whether it is to the right or to the left, to the east or to the west. In this case, we have east. So the bearing will be north 45 east. So if the central angle measures 120 degrees, what is the arc length intercepted by this angle? The arc length, we usually use the letter S for it. So when we have the formula S equals R times theta, so we need to know R also. So, and important here is to remember that theta must be in radians. So first we must convert 120 degrees to radians. So it means we multiply 120 by pi and divide by 180. So if we have an angle in radians, we usually have pi there. So 120 divided by 180, both numbers are divisible by 60. 120 divided by 60 is 2, and 180 divided by 60 is 3. So theta is 2 pi over 3. Then we substitute 5 for r, 2 pi over 3 for theta, and multiply. If you multiply number 5 by the fraction, we multiply only the numerator. So 5 times 2 pi will be 10 pi divided by 3. This is the arc length. And then let us convert the radian measure to degree measure. So 3 pi over 2 convert to degree measure. We'll just replace pi by 180 degrees. 3 times 180 divided by 2. 180 divided by 2 is 90, so we have 3 times 90, 270 degrees. 5 pi over 6. We replace pi with 180. 5 times 180 degrees over 6, since pi is exactly the same angle as 180 degrees, and simplify. 180 divided by 6 will be 30 degrees. 5 times 30, 150 degrees.